Hello again, everybody, and welcome to another Geo-Institute live stream. As we draw to the end of the Geo-Institute Summer of Live, we are very excited today to bring you the first sneak preview for the Geo-Structures conference that is coming up in November of this year. My name is Brad Keeler. I'm the director of the Geo-Institute. And once again, welcome. If you don't know anything about the Geo-Institute, after you watch this today, let your fingers take you over to geoinstitute.org on the device of your choosing, and there you will find out many things, including we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and I think you will, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. There is a lot happening in GI land today. For one, and we'll just get this out of the way right away, you will note that one Sebastian Lobo-Guerrero has worn a Pitt football t-shirt for this occasion. Saturday being I don't even know what edition. I think it's the 103rd, maybe, edition of the Backyard Brawl, the Pitt, West Virginia University football game. I've got my WVU hat on, celebrating the college freshman in my home, who is a student at that august academic institution in Morgantown. And so Sebastian and I may trade barbs a little bit here, but there will be no harm meant. The second thing that is happening that is enormous is from time to time, actually 6 times a year, we post a Geo Legends interview to the YouTube channel. This very morning, Paul Main's interview was posted. Dean Harris at Jacobs conducted that one. Paul Main, of course, of Georgia Tech and a lot of bands. Guy's a great musician. You can bet he talks about that. So you want to go check that out as well. The third thing, and Jay's going to tell you a little bit more about the fourth thing in a minute, but the third thing is that the student competition rules for Geotechnical Frontiers, which is Geo-Congress 25 plus the Geosynthetics Conference, are posted today. Keep looking out for information about those if you want to participate in the student competitions. The fourth thing is that we're going to talk about this Geo-Structures conference that we mentioned at the top that's coming up. That's the whole reason that we're here today. It will be, of course, from November 17th to the 20th in Pittsburgh, PA. And here to tell you a little bit more about it and introduce our speaker today is the conference chair, Jay McKelvey. Jay, tell us what we need to know.
Well, thank you for all that, Brad. Hi, everybody. I'm Jay McKelvey, Conference Chair of Geo-Structures 2024. We're really excited. This program has really come together. We've got here up on the webpage is a brief description of our objectives. This is a specialty conference focused on earth-retaining structures. We posted the technical grid just today. And I encourage you to go to the site and you can take a look at it, but we've got some really cool technical sessions planned. We have keynote speakers from across the country throughout the conference. And we have panels and what we call session panels the session panels are almost like short courses that will be held throughout the conference. Sunday morning, we'll have 5 different short courses that are available to you. So please take a look at that. We're really excited to offer you this live stream today as kind of a sneak preview of some of the content that we expect to see at the conference. So I do encourage you to stop by and check that out. So what gives me great pleasure is to introduce today's speaker, Sebastian Lobo-Guerrero. Sebastian's a geotechnical project manager and lab manager of the AGES office in Pittsburgh. Sebastian teaches at the University of Pittsburgh as an adjunct. He has 23 years experience in geotechnical engineering. He's focused on deep and shallow foundations, earth retaining structures, of course, and landslide stabilization. authored over 200 papers. I don't know how he gets any work done writing all these papers. He's got them in scientific journals, magazines, conference proceedings. He's co-author of the State of Delaware's LRFD Bridge Design Manual. Pretty cool. Sebastian's been a former chair of the Pittsburgh ASCE Geo-Institute, former director of the Pittsburgh section. He's a member of DFI's Earth Retention Committee and a conference chair for DFI's 2020 conference. He's on the board of trustees of the Academy of Geoprofessionals, and he's got a whole host of awards and recognitions, the 22 DFI President's Award, 21 ASCE Lifetime Achievement. The Pittsburgh section gave him the ASCE Civil Engineer of the Year in 2020. He's been a distinguished reviewer for ASCE and has received the best paper on numerical model. So quite the credentials. This presentation that Sebastian is going to present today, I've seen it before. It's quite excellent. So without any further ado, Sebastian, take us to Pittsburgh and tell us about your cool project.
All right. Thank you very much, Jay. And of course, welcome to Pittsburgh. Let me try to share the screen. Should be seeing my slides, right? All right. So you see my presentation there on the screen? Can you just confirm?
We've got it.
All right. So let me get started. So, well, thank you very much. Thanks for the introduction and thanks for the opportunity to present about this. I guess the idea today is to talk about a little bit about the city of Pittsburgh, trying to see what the conference is going to be about. This presentation is not going to be on the conference, but the idea is that it gives the flavor of similar projects. So to begin with, the topic is the Sports and Exhibition Authority CAP on Pittsburgh downtown. It's basically a floating park that we have on top of the highway in the middle of the city. I always like to start the presentation with this picture because it's the scanner, it's the ASCE scanner, the American Society of Highway Engineers scanner. We got the cover with the project a couple of years ago, and it shows the project. But I always say that most people see this and they believe that we designed the UPMC tower because that seems what is highlighted on the picture. In reality, what we did is something that I can guarantee 99% of the people are not seeing, which is at the bottom, you see a park, and that park really is what we did. So let me just put the pointer here. This here is the park. And what you have no idea by looking at this picture is there is a highway that is passing under all of these things. And the beauty of this project is how can you do these kind of, coming back into downtowns, in this case in Pittsburgh, that were divided by highways and trying to integrate the city and putting something on top that brings back a lot of things that were gone since the 50s. So that's a short intro of what we're going to see today. Thanks for the introduction, Jay. Just complement a little bit. I'm originally from Bogota, Colombia. That explains the accent and the speed that I talk. I cannot change it. At least I'm not drinking coffee. That will make it even worse. I came to Pittsburgh. I did my master and PhD at the University of Pittsburgh. That's where I also teach. And then for the last 18 years, I've been working at American Geotechnical and Environmental Services. It's a local firm. It started in Pittsburgh. We also have offices in Philadelphia. We also have an office in Washington, D.C. And we specialize in transportation geotechnics, basically air retaining structures, foundations, and light stabilization. So this is pretty much what we are going to be covering today. The outline is a project summary, the geology and a geotechnical model for Pittsburgh. Obviously, Pittsburgh is a very complex region. I'm just trying to show you what is on downtown and the projects that we do there. We're going to talk about micropiles. We're going to talk about caissons. We're going to talk about the construction of the structure, a little bit on the structural aspects. And something that I also want to focus heavily is on the community relevance, because I went through this project, we extended through a big amount of, many years. And the community relevance, I have to say, from an ignorant point of view, I never really understood it at the beginning. And I was just treating it as any other engineering job. And it's probably the coolest project that I have done from that aspect. Obviously, if we have time, we can resolve some questions at the end. So to get started, the CCAP, the name comes from the Sport and Exhibition Authority, CCAP, but it has a lot of agencies also involved. The problem really starts in the 50s when they are doing the infrastructure, like the interstate highways, and they basically divide downtowns. And Pittsburgh is not the only case. That's the one that we are focusing today, but this has been repeated. And we actually have been lucky that now we also have been working on the cap for Philadelphia, which is currently under construction. But this story is on every downtown. You have the highway. The highway passed through the middle of the city. At that time, the priority was just connect and transport. But you end up having this open wound, if you want to call it, in the middle of downtown and isolate sectors of the city. So that happened with Interstate 579 in the Crosstown Boulevard. And the idea is to connect the city back, to bring the different sectors back. The project is a 3-acre public park. It has pedestrian and bicycle routes. And the idea is that it's going to be at the top of the highway and it's going to be absolutely camouflaged. There is many stakeholders on it. The Pennsylvania Department of Transportation obviously is involved because that's the highway that is there. Sport Exhibition Authority and Pittsburgh Penguins. I guess it's a better way to describe it. It's really the Penguins, the ones that own the facility that is next to it, which is the PPG Arena. And this actually is envisioned for the Pittsburgh culture of enjoying these games in having a space that you can, before entering the stadium, you can gather and watch games and celebrate and all that. So this concept really started decades ago, thanks to a lot of politicians too. I don't know if I always talk good about politicians, but in this project, definitely I will, because it was thanks to them and their vision that they have that this became a reality. The project team and cost, the construction cost was about $32 million. It takes a big team to do something like this. Fay was the general contractor. McCrossin did the drill shafts. Amelie did the micropiles. You obviously have the city of Pittsburgh as a partner, PennDOT, and HDR was the prime. They were the structural designer, and we came under them. In terms of foundations, FTG, Foundation Testing Group, helped us a lot with a lot of the testing that I will present. So a geology of Uptown Pittsburgh, I'm simplifying this for the sake of time and just to keep it simple, but in general, in Pittsburgh downtown, you have a little bit of field that has been placed through the years. In this part, we have about 5 to 20 feet of soil. Then you have about 20 feet of claystone. Claystone, and in general in Pittsburgh, we have red beds and we have shale and we have materials that are, it's basically a clay that has consolidated and became rock, but it has the problem that it's extremely weak and it weathers down extremely easy. So it's always a challenge because you don't want to put all your load into this. If you are looking at the spread footings with low bearing capacity, it may work, but on something that requires higher capacity, you have to bypass that. And then you go into a 15 and 20 feet of sandstone, which is a way better layer, but the problem is that you go back into another claystone below. So it's always the trick of having this sandwich of good sandstone between two bad claystones and trying to put all your foundation in that. Picture that you see on the right is during the excavation of the drill shafts, and it's just showing the kind of equipment that we use. I know this is hard to follow, but I have to follow it. This is a plan of a cross-section better, an elevation view of the bridge. It's not the biggest bridge that you have seen in your life, and I'm sure this probably will not be that impressive. I mean, you can see it's about 3 spans. First span is about 55 feet, second one is 92, third one is about 91. It may not be the longest, but I can almost guarantee you that it's the widest that you have seen in your life. It's also extremely complicated because you have the piers in the middle of all these lanes of highway, and it's extremely difficult to construct. So for the piers, the selection was drill shafts because it minimized the disturbance and it doesn't require to have a pile cap. And then for the abutments, we try to avoid interfering with the existing retaining walls. The retaining walls that are there have been there for decades. And one of the priorities that PennDOT had was that they did not want any interference. So on the abutments, we have to put vertical loads on vertical piles. But for the lateral loads, we end up using micropiles battered backwards. And this is kind of a new concept or something that is not used that often, because typically for lateral piles, you want to put battered piles towards the front, right? That makes a lot of sense. That's how you resist lateral forces. But in this case, we did not have the luxury of that because we will damage the existing. So all the design really was based on accommodating to the surrounding conditions and then, trying to make these battered micropiles work. So that's basically the principle of what we had. Now showing it into the different parts, the different elements, the 42 caissons are basically allocated in 2 piers. You can see it here on the left. They are single caissons come up and merge into a cap in the part of the pier. And then the micropiles, as I said, this is one of the abutments. The other abutment is to the left, and they are battered backwards. So 42 caissons to 120 micropiles, all in the middle of the city, trying to make it work while having the highway completely open. The micropile design, I'm not going to spend too much time here. Micropiles are basic design by now. We have complete methodologies. They are covering on DM4. They are covering on ASCE. basically what we are doing is you are taking the perimeter of your hole times the bond times the length, and that gives you your resistance. All this comes from tables. I always said at this point, and after using micropiles for so many years, we can design this based even on the color of the rock, because you just get an idea of, what is the material, what is the bond, but then you're going to test, and you're going to test all these, to make sure that your resistance was appropriate. Some peculiar thing on this project is that the design load that we used was 432 kips. To my understanding, is the highest that has been used in the city of Pittsburgh for a transportation project. But what is more impressive is the load that we take it during the test. So that's just the principle of the micropiles. On the left, you have the test that we took it to the highest resistance. For everyone that has seen me before and knows about me, I'm a big fan of selfies. I'm very proud of what we do, sharing what we do. So I could not avoid having that picture, celebrating the result of the test. Obviously, this has to be done after the test is done. You don't want to climb the frame and the beam while the test is being done. The person on my left is Taylor the Canal. She's one of the key players on this project. She was also extremely involved in the project. On the right, we see one of the details that we have on the micropiles. The length of the bond was 14 feet. This is traditionally it's a standard value. It's not extremely long. The reason that is 14, and which is an odd number, is because we were trying to minimize being on that sandstone layer in the middle and not punching into the underlying clay. So it's tricky because you want to have enough elements. Obviously, you will tend to make longer elements to reduce the number of elements, but in this case, you couldn't because you will be punching below. So that was pretty much the principle. All kind of group effects. We have to analyze it, basically going back into the Ashton FHWA principles. We have these loads. We have to take the loads and project them from the pile group and make sure that we are not punching into the layer below. So obviously, group effects have to be considered. This is something that is typically done in the city of Pittsburgh in downtown because of having these layers, these alternating clays. All right, the micropile installation, it's relatively simple. The technologies that we see in Pittsburgh obviously are the same that we see in the rest of the country. We have the casing goes down, you're drilling through. You have the Numa just bits, they go inside the casing, they open, you drill as a unit, you establish your bond, you close it, take it out, leave the casing, put it. I'm a big fan of all the time to test a picture take a picture with the first foundation element. So what you see there on the left is me in a bunch of concrete, just celebrating that we were able to install the first micropile for the project. And then we go into the micropile testing. Not every element is tested. We have verification tests, about 5% of the production ones, and a good amount of number of verification is starting on each substructure. We have tension in compression. We did verification. As I said, we have verification and proof. Part of what Taylor always gives me grief is because I obviously took the first picture in September 2019, 5 years ago. Extremely excited about this test. It was sunny. It was nice. And then she ended up covering the ones during the winter. So she always said, why do you always go when it's sunny and nice, and I have to go for the ones that are muddy and rainy? The micropile verification test, it's a standard test, not really much to talk about it. The thing that I really like to show here is that we took this element to 200% of the unfactored load, which is 576 kips, 2 verifications per abutment. And I like to reflect on that number because 576 kips is a lot of load for an element, for anything that is called micro. And that shows the resistance that we have in the city of Pittsburgh and how good this sandstone could be. So, as far as I know, this is the record on micropile for DOT in the city itself. It was successful. We did not have any effects of creep or any signs of distress or any kind of failure. The criteria, not going to bore you with all these, but just quickly, maximum plastic deflection of 1/2 inch. Again, what is important on these micropiles is not the total deformation, but is the total, and then you subtract the elastic to see what is the interface deformation. You don't want to exceed 1/2 inch because that's when you go from peak to residual. So that's the first criteria. The second one is in the first 10 minutes, you have to have less than 0.04 inches. You don't want any creep effects. And if you do elongated test, then you do 0.08 and 60. And you want to make sure that you don't pull out to failure. 5% of the micropiles, as I mentioned before, on the proof were tested. We review every single one of those, every single one of the logs. That's something that the city of Pittsburgh and PennDOT are extremely strict on that. When you're working in these kind of conditions and, with the implications with all the structures around it, quality control and quality assurance is extremely important. And they want the design team to be involved during the construction to make sure that everything is accordant. So that's something that it was very enjoyable on the project. I think it's important to work together with contractors. The caissons for the piers, the design were 42 inches or 36 inches, believe it or not. The reason that we have 36 inches is because literally we did not have enough space. I have never done a drill shaft just because of a space requirement being so tight. Keep in mind, this is still the lanes are open. So, utilities, all kind of things. The casing, they have temporary casing in the soil. Once you go into the claystone, into the first claystone, you don't have to have the casing. The claystone is competent enough. Obviously, that's what I'm telling you now. But when you are doing contracts in the city of Pittsburgh, you have to be careful and recognize that there may be a need for temporary casing on that top claystone. In this project, fortunately for the contractor, it was no need, so it simplified the process. And we were going 9 foot into rock. You may ask, why 9? Why not 10? One, another number that is a little round. It was the same. It was just to avoid punching into the underlying layer. So it's very unique. I think I have never done a project with 9 and not rounded to 10, but that's what it was. Then on the right side, you're seeing the first drill shaft that was installed in the project, or the first 2 that were installed in the project. I'm obviously smiling there. I want you to remember this picture. I'm standing there, and you see this. Look at those signs. It's Bigelow Boulevard and all that. Because you're going to see how after the project, this looks absolutely changed. The drill shaft itself, we have CSL tubes. We also have tip cables and, everything that we have now, obviously, on all these projects, right? All the centralizers and boots and things like that. All right, the Caisson installation, in this case, as I mentioned before, the micropiles were done by Amelie Construction. The caissons were done by McCrossin, excellent companies. We did the mini seed. Mini seed is intended to see if you have enough sediment or that you don't have too many sediments at the bottom. So it's basically this inverted bucket with a camera on top. And what we're doing is just rotating it around the excavated shaft, making sure that we have limited sediment. You want to have more than half the area with less than ½ inch and a maximum of only one occurrence of maximum one inch. In this case, we were going this strict, even though we did not account for end bearing. We designed them only on site friction. It's debatable if you can, and if you have seen my presentations on drill shafts and the state of the art on that, I like to combine site friction and end bearing. In this case, because we have that claystone below, I definitely wanted to stay away from that. And I wanted to only depend on site friction to minimize the potential for punching. So even though we didn't need this strict, I guess, of criteria on the end bearing, we still wanted to keep it just to make sure construction was done properly. After everything was done, the shaft was installed. We did CSL testing. CSL testing, I'm sure most people are familiar, but just a quick summary. You put a sensor on one, you send the wave to 2. You basically load the 2 sensors on the access pipes. Let me just go back a second. These are the access pipes, what you look here. So you lower them and you measure the waves. You measure compressive wave. You look at the time that it takes. You can calculate velocity, but in reality, what you really want to see is there is a drop, if there is some kind of drop in the, in velocity or in increase in time, because that will be a sign of an anomaly or a defect. So we did CSL standard. This is all on pendle requirements. You're supposed to, at the time, I guess we were doing a transition. These days you are required to do TIP, and if you have problems, then you do CSL. This actually was a pioneer project on that. It was one of the first ones that utilized this methodology. So we only did CSL on the ones that reported anomalies or problems with TIP. The regular construction, you put water on the pipes as you constructed. Once you finish, then you put the sensors and basically do what you see on the right. We also did TIP. TIP was, in this particular project, TIP was considered as the main tool to determine if the elements were competent or not. It's temperature monitoring for those that are not familiar. The last thing that I want to talk right now, it's a second integration of Laplace differential equation for energy, but I'm sure we all at some point in our careers came across that. That's the way that we solve flow of water in soil. That's the flow nets that we did, when we were studying and all that. So TIP is pretty much the same. What you're doing is flow of heat. If you don't want to solve the double differential equation, just look at it as a correlation. If I know the volume of concrete that I have, I could say I know how much heat has to generate. So if I put sensors around my shaft, and I see the temperature, I can correlate and see if it's adequate or not. Look at it also this way. You can say if I know the temperature, I can back calculate and see how much concrete I have. I can create what is called an equivalent radius, which is not a physical radius, but is an equivalent radius of how much concrete you have. Now, if that equivalent radius is bigger than the physical radius, then that means it's good. You put more cement, or you actually end up doing a bigger caisson. When it's less, which is called necking, that's when you have issues. It could be because the hole collapsed, but most of the time it's not because of that. The actual hole that you did is what it stayed, but it's just the quality of the cement or the quality of the concrete is lower than you thought. It probably has less cement and it generated less heat. So that's what is called TIP. That's the standard these days on Pen.world. TIP is done for every drill shaft, and if you have anomalies, then you go and do a CSL. So in this case, we did have anomalies with TIP, and we end up seeing that towards the bottom, it was a significant reduction on heat. That can come from two reasons. One is truly having the sediments, or the fact that when you have TIP towards the end, towards the bottom and towards the top, you will have different temperature exchange that in the middle because you have boundary conditions that are different. You have air on top and you have rock below. There is a correction that is called the roll-off effect corrected, and it's typically done by the software. All this was developed by GRL and PDI. It's an absolutely outstanding product that I absolutely supported. But obviously, there are certain things like this that probably the local geology, and that's really what I want to point today, probably the local geology was not really matching with the standard corrections. So because of that, we have to go and do, drilling into some of the drill shafts that we had. So this effect was not really observed on every single shaft. It was just on a few isolated ones, but it was enough to generate some concern. Difference, the TIP was showing concern. CSL was not really showing that much concern. So the only right answer is go and drill core and get out. And you can see by the smile on my face and Taylor's face that, we end up coring through, and we got absolutely good concrete, and we tested, and it satisfied the unconfined compression requirements for the project. So it was concluded that it was not an issue, but it taught me a big lesson about TIP tests in Pittsburgh downtown, because that unit that you have there, that sandstone definitely has an exchange of heat that is a little different than in other areas. And your TIP results may be biased a little bit for that. So the important part is not panic, just keep it in mind, right? And adjust. And if necessary, nothing beats this, right? I'm a very simple person with very simple beliefs in the sense that I think engineering has to be done by gods. I mean, geotech engineering is an art more than anything else. And it's important to be comfortable with what you're doing. And if something is not matching, well, try to look for ways around it to prove it or find the problem. So this was very successful, and it was used to basically confirm that the shafts were good. Not often you will see somebody showing pictures of their mother during a presentation. So that's my mom, for everyone that has not met her yet. I'm a big fan of mixing life and work and everything. I think by now it's not a secret for anyone. I truly believe that it's important to enjoy what we do. I mean, I believe that geotechnical engineering and civil engineering as a profession is something that is extremely prestigious. I grew up in Colombia going to job sites with my dad, which was a contractor. And I mean, I don't know, until the age of 10, I didn't even realize that there were other jobs than not civil engineering. And I guess after that, I didn't realize that people were not crazy about being civil engineers. They actually like other things. But anyway, so I look civil engineering and geotech engineering as something very, very prestigious. It's my life. It's what brought me to Pittsburgh. I would not have come to Pittsburgh. I would not be talking to you today about a conference in Pittsburgh if it's not because geotech engineer brought me here. So I share that with, I share that with family. I share that with friends, obviously coworkers, and I celebrate that. So I know this is gonna sound crazy, but I do take family to construction sites with the proper precautions, right? And following OSHA requirements. But I love to share what I do, right? And the same goes to share all this on LinkedIn and Facebook and things like that. So, that's what it is. So I took my mom there to show her. She was visiting from Colombia, and you can see her face, a lot of concern. So I got concerned that she was concerned that something was going wrong, but apparently the concern was just more because of the heights. This was abutment 2, and we have the micropiles, and it was a drop there. You can also see my son towards the beginning of construction of the project. You're going to see in a second a lot more pictures of him. You can see how he grew as the project developed. But anyway, November 2019, most of the foundations were being completed. Family concern, not really that much, but everything was going great. And then obviously COVID came along between these two slides. So I don't want to sound insensitive, but obviously COVID had very negative things, a lot of negative things, but it also had some positive things. And for this project, it helped a lot on the construction time because by the fact of not having that much traffic on the highway, it gave a lot of freedom to do a lot of processes a little faster. So by June 2020, and you can see the picture on the right with me and my son with the masks, we just keep moving and it was faster. By that time, all the foundations were completed. All the drill shafts were completely constructed. You can see them behind me. Micropiles are installed. And at that point, we start placing the beams, which placing the beam sounds like a small operation or not a small operation because it's something extremely important. It sounds like a short-term activity, but it's not when you are putting this across the entire cap. I mean, you are covering a significant part of downtown all with these beams putting on the foundation. So keep in mind the timeline because it's interesting, right? So we started the fall of 2019. By June, we already have these, we're putting all these beams. Then, it took almost a year of putting those beams and then start constructing. And this part of the presentation is when everything changes to me as an engineer on this project. Because up to this point, what I was looking this is another regular project. This is just what we do. This is what we have been doing forever, right? We design these things, we go to construction, and it's done. And that's when I really start understanding the relevance of this project and why it was so unique. So a whole year passed, right, since we posed this, and not, in your opinion, maybe not much is done, but it's a ton. You are constructing a park. You have to bring, you have to bring soil. You have to create little mountains. You have to create little ditches and channels. This is not just a bridge. This is not what we always just do, right? That is finish, pave, open it to the public, and that's it. So by August 2021, I know we all managed the pandemic probably a little different. I was bored to hell. I was doing a lot of stuff on virtual presentations and things like that and visiting my projects, but not much after that. So we came with the idea of renting a helicopter. And believe it or not, renting a helicopter is cheaper than what you imagine. You can Google it, and I'm sure you will have some local helicopter in your region that you can rent and go around. And what I wanted to do was to go and visit a few projects from the air. My hope was to take some amazing pictures. So I went with my wife and my son. You can see them here. And then we went here and we approached the city of Pittsburgh from the air. It's a beautiful view. But the sad part is I took the pictures, and then I remember my son was the first one to point it out. And he said, "Where was the project?" And again, people believe that I was involved in the design of the UPMC tower, which is not. This is the project right here. Absolutely camouflaged. It seems that we took a helicopter ride just to take pictures of a parking lot. But again, the part that is insane to me is that through all this, you have, a huge highway that is passing under. So maybe not the best investment, to go into a helicopter ride just to take this picture. Probably I could have done a way better job just with a drone, but it was a good memory. And at that time, it was a lot of fun. By November of the same year, things are being constructed. I mean, things are being finalized. This is a picture of my son visiting the job site. You can see, like all these plants are being put into place. You have the trails, you have different things. This is completely sustainable. I mean, the energy comes with solar panels. All the water is, all the water that goes as rainfall and surface runoff, it's collected and it's used in the park itself. So it's sustainable and it's a lot of green infrastructure. This is the way that it was looking in November. And now, remember the first picture that I showed, remember that is the same sign. So now when I took the picture with the drill shaft here, everything is in place. And now this became a tunnel. It literally became a tunnel because it's all covered on the top. The city had many complaints about motorists because at the beginning they said it was too bright when you are inside, and they actually work with a company from Canada to get the right balance that you go into this fake tunnel and you don't get, when you come in and when you come out, you don't have a visual thing. Now, I also love this picture because it really reminds me of all the adventures we were having with my son. I know it looked like a great picture, but just think for a second, how the hell you take this picture? Because it's the middle of the highway, and clearly, like, we are there and you have cars going. The operation was, I'm driving, my son is in the back seat, obviously with all the safety that it needs, with my phone, open the window and trying to take this picture. And I'm hoping that my phone is just not gonna drop and all that. But it worked. Finally, I got my phone and, we took that awesome picture. So by November 2021, I feel the project was changing. I mean, it was completed, but I started seeing something that I never thought that was gonna be that cool. which is it started bringing the community together and from all levels. So on November 2021, we have the official opening with the Pennsylvania governor, Mr. Wolf, which is here. And I told him my last name is Lobo-Guerrero, which in Spanish is Wolf Warrior. So say we're almost cousins from different continents. He did not find that funny. But anyway, so he came here. We took the picture. He was the one opening. You have the major, Bill Peduto, the major at that time. We have, people from our company, KP Chopra, which is the owner. Taylor worked very hard on this. And Roger Eaton from HDR, he was the project manager. And to me, it was very interesting because I started seeing this, what you see on the right. It was a lot of media and a lot of people coming to this. And I'm not used to that. Most of the projects that we work, we finish it and, people use them, but we don't have like something like this. So I started seeing that this was meaning something for the city of Pittsburgh, that it was not just one bridge that we did, like that the community really was going to start enjoying it. So, the same time, November 2021, we started receiving a lot of invitations from different organizations and from different events. I started traveling and presenting this project and sharing the idea. And it was really exciting to see how many people were interested from different cities, right? And this is something we can use also in our city. And this was, as I said, we end up doing the Philly Cup. And as far as I know, there is plenty of cups that are being right now designed and constructed in the US. I also got some invitations from abroad because they also saw it as a very, as a very good idea to have. So, I've been in different countries, in Mexico and in Costa Rica, and, similar ideas and similar concepts they are doing. Then things start really taking off February 2022. So we got the ASCE Pittsburgh Project of the Year Award. That to me means the world. You can see the smile of our entire team there. Because being recognized in a city that you came as a student, right? I came to Pittsburgh as probably a big amount of people listening to this. Came here as an international student. My only objective was to get an education here, try to graduate with a master's, if possible, go for a PhD, maybe find a job here, try to go from an H1 into something that lead into a legal way to stay here. And receiving an award like this means the world, especially for a city that you love and you have spent, half of your life. I'm 45 years old today, and I've been in Pittsburgh 23, which is more than half of my life, right? So you can see how personal this started getting to me, right? So we got that award because this was such an adventure with my son during the design and construction, especially during COVID, right? I have all these memories of taking him from school and going to the project site. Fortunately, nobody was really looking because it was COVID. Nobody cared, I guess, at that time. So I went to his school, I went to his class. I actually shared the same presentation or very similar to what I'm showing today, going fast in certain areas. But it was very special. It was very special to see these kids also, getting the idea. The professor, like the teacher at that time, Ms. Mary Cole, she was teaching them about community bridges, right? And how to integrate different people. So it went into that, more invitations, more presentations. Then in the summer of 2022, we have a second opening of the park because now as this was the first summer. And if I don't give you the context, this was going to be the less impressive picture you will ever see in your life because it's just a park, right? If this is on grade, it's just a park. You just put some flowers and stuff. All this, including what I'm standing, it's above a highway, right? And again, I have nothing to do with the UPMC tower. That was constructed during the 70s. So you could see that things were going really, really great. In the summer of 22, we got a ton of awards. We got the March of Dimes Award. We got an IBC, the International Bridge Conference. We got a medal on that one, which again to me is great because recognizing that the IBC is seeing the importance of these kind of structures is great. I also got to meet some local celebrities. Rick Sivak. If you are thinking Pittsburgh, Rick Sivak is a must. He has done the history of this city. He has all the documentaries with the public television, WQED, part of PBS. He regularly appeared on PBS with different documentaries. So it was really cool to see that, this was meaning a lot to many people. We presented at the local Geo-Institute, of course, in the fall of 2022, standing there with Taylor. And then I started seeing that the American Society of Highway Engineers also got interest on this. So we got an award for the project of the year again for the city of Pittsburgh with ASCE. And I end up singing in this picture, I end up singing with the guy that sings the national anthem at the Pittsburgh Penguin Games, which is quite an honor. And then it got even more weird. We got another ceremony in the winter of 2023. But now we have another major because Pittsburgh changed majors. And I do the joke, and I clarify it's just a joke. This is the only award that I have that is the definition of sustainability because different politicians claim, the idea and claim the project. So it's recycled, but it's not. in reality, this was a lot of people thinking. Mayor Bill Peduto was a key part. He finished his term, and he did the first inauguration. In the following year, we got probably the biggest award that we have on this project, which is the ASCE Project of the Year at the national level. And that award actually comes with a lot of money. So we got the city involved. We got the county executive. We also got PennDOT. This was the Secretary of Transportation at that time from PennDOT. And we actually end up collecting even more money than the award, and we give it to the community. So the community, and that's something that I haven't mentioned, what was isolated when the construction of this was going on is what is called here as the Hill District. The Hill District it's a beautiful area of the city that was completely cut from downtown. And the idea with this is to integrate them back. That's the whole, the park is full of murals that tells the story and all that. So all the money end up going to youth clubs and youth organizations in the Hill District, and it's probably the best thing that we could have done. But then we continue, and then we start getting awards from the ACEC, the American Council of Engineers Companies, and we keep collecting them, and then we continue with ASCE. We got articles about the project. We got more recognitions. So far, I believe we have, it's not 14 anymore. I think we got one a couple of weeks ago, and it's 16. Nobody is counting, right? But we do, right? This is important for us. So we got very important awards like the ASCE Pittsburgh Project of the Year, WTS, Women in Transportation Sector, Engineering Society of Western Pennsylvania, and as I mentioned, others, so it is great. And it's great to see that the community appreciate that. So obviously, we have articles about this and different aspects. If anyone is interested, I always say, let's connect on LinkedIn. That's the easy way to share information and pass links and everything like that. And if you like, obviously, look me up on YouTube. I don't have a channel, but we have a lot of presentations, a lot of things also with Geo-Institute and with Brad that we have put through the years. So yeah, I mean, always available and ready to share what I know. So that's all I have. I don't know if we have time for a few questions.
Well, thank you, Sebastian, for a wonderful presentation. A couple questions for you. Actually, I was just curious, did you use the PennDOT design criteria for the design of the shafts and the micropiles?
Yeah, that's a good question. Yeah, so everything was done in accordance to PennDOT DM4. So obviously in Pittsburgh, that's the code. That's the code that we use. However, we did needed some exceptions because typically, I mean, like the drill shafts and all that part was a standard design in the sense of DM4 is based on AASHTO section 10, so it's all specified there. The fact that we were not using embedding make it a little conservative, so that was simple. But we have to have all these group effects that sometimes is not that clear in some of the manuals. So we end up expanding a lot into that. But the biggest thing that we have was the micropile being battered backwards, because I'll go back and explain a little more on that, but let me just take my pencil. When you have a lateral force, what you want to do is to batter your element, right? So if I push this way, the axial resistance multiplied by the sine of that angle is going to give me my lateral resistance. That's the reason that on a regular bridge, on a regular abutment, or a regular foundation, you batter in the direction that you get the maximum resistance coming back to you, right? So in this case, we couldn't do that because we have these walls from PennDOT, and it was very clear from them that we could not interfere the walls, which is very complicated to do when you have walls that have been there for 70 years or something like that, and you cannot touch them, and you are trying to do foundations around them. So the way they're doing is that we put the micropiles but backwards, right? And they work in tension. So obviously, when you have an element that is designed to work in tension during the service life, that requires a special permission. So we have to submit. We were working together with central office, PennDOT central office, and we basically got the design exception for that and the authorization. I mean, it was done conservative. We actually took the capacity and we divide by 2. So for those lateral resistance, and the only reason for that it was to avoid any creep effects. And when we did the testing of those micropiles, we were very careful to make sure that creep was not an issue. Besides that, it was a regular PennDOT standard and PennDOT procedure. PennDOT, as you mentioned at the beginning, I have the luck to be one of the co-authors of the State of Delaware Bridge Design Manual. As a result of that, we review a lot of the codes around, and it's Pittsburgh really or Pennsylvania really have one of the best design codes, which is DM4, and it's free. You can find it online. So if anyone is listening that is not from Pennsylvania, I mean, absolutely check that reference, because it's really a good manual for design. So
excellent. Hey, folks, if you have any questions for Sebastian, feel free to put them in the chat box, and we'll make sure he knows that. The in-situ testing for the caissons, did you get a reduction on your resistances, or because you were doing those particular tests? And can you elaborate a little bit on that?
No, excellent question. Excellent question. Yeah, I'll be happy. So, yeah, the way that PennDOT works is it may be different than in other areas. So the way that PennDOT see it is all these quality control tests are really expected to be the standard, right? So you are not going to get any reduction, right? You're not going to get any reduction by using them. It's considered the standard. What you could have a reduction is if you do micropile tension testing before design. So if I go before the project, I install a micropile and I test it and I get the bond resistance, and then I design with that bond resistance, I could increase my resistance factor. But that was not on the project. Basically, we designed as we have a subsurface investigation, comprehensive subsurface investigation, extensive laboratory testing, a lot of unconfined compressions on all these materials, on all the rock, and then we assume a bond value, and then we test it during that. So the testing basically, the in-situ testing basically divides into what I was showing. You make the hole, right, and then you're doing the mini seed to make sure that the bottom is fine. We also have a downhole camera. I didn't really present it on the downhole camera. The downhole camera is just to see the side, right, of the wall. The problem is when you have the water table, in this case, the water table was right at the top of that sandstone. So when you are trying to inspect, the water was always turbid and it was impossible to see. So we end up having the mini seat on the, on the bottom part. That's before construction, before putting. And then once you construct it, there we have TIP as the standard. And if we have anomalies, then in that case, we did CSL. And in the ones that we found the issues that I was mentioned, then we core as a third, but that is a destructive only way to see it. Obviously, once you finish, then you inject grout into the hole and you really did not damage any of the integrity of the structure. But yeah, but those tests are really considered now the standard, and you don't really get additional benefits as of right now.
Excellent. So the claystone there in Pittsburgh, that's particularly problematic, right?
Yes.
And you pretty much all but ignored the presence of that in terms of strength? Or?
Yes, I know. And that may be surprising for some people, right? But I mean, to me, it's not, because I grew up in Colombia and in South America, we have a lot of shales and a lot of claystones, and we kind of grew up used to the fact that you can have something that is a rock, you expose it to water, and it disintegrates in seconds, right? The Panama Canal with the Culebra Shale and the Cucaracha Shale is pretty much that, right? And in Pittsburgh, they have the same, and it's called the Pittsburgh Red Beds. So the Pittsburgh Red Beds are the worst, which is this clay material that could be a claystone, it could be a rock, but it disintegrates really, really easy. I live right now, I'm at home, and I live next to Shenley Park, which is the equivalent of Central Park on New York here in Pittsburgh. It has beautiful trails, and you have shale and claystone exposed everywhere. So what I was doing during the pandemic, I was walking with my son on the trails, and I was getting his attention by showing him how you can collect one of these pieces of rock, right? And then you take it home, put it on water, and disintegrate. I also recommend the same to my students because it's pretty impressive. So that's a signature material of Pittsburgh. And anyone that works in this region, it's always aware of that. So I know it sounds insane, but yes, literally we neglect the presence of that claystone. And it's not a small seam. As you saw on the presentation, it's a thick seam that you are ignoring, right? And when you look the group effects, what is below, you really have to treat it as if it's a stiff clay, not even a rock. So I know it sounds extreme, but once you have been born enough times on seeing how that material behaves, you will do the same thing that people did on the Panama Canal when they were constructing, right? It's at some point you cut your losses and say, I'm not going to keep seeing failures by assuming that this is rock when in reality, it's just a clay, right? And you eventually just decided to ignore it.
Nice. Got a question from John McMillan. Would like to know how the test frame was tied down.
Yeah, so correct. And that's always the question, because I mean, I didn't really spend enough time on that. I have a whole presentation that is about the state of the art of micropiles, but there is a big difference if you do tension or compression test. If you do compression test, you have your element, you put your jack, you have your reaction beam, right? So if you're doing compression, you push down, and when you push down, the beam is gonna go up. And if the beam goes up, now you need to have reaction anchors. So I typically don't like to do a compression test because of that, because it's gonna cost a lot more, because you need the reaction anchors to hold the beam down. I'm a big fan of doing tension test, because when you do the tension test, now you have the bar, you have the jack on top of the beam. When the jack opens, it pulls the micropile, but it pushes the beam down. And when you push the beam down, now you pass the force to the soil as little spread footings that you can do with the wood craving and stuff like that, and it costs you a lot less. So even though, I mean, in a micropile, in theory, it's the same if you test tensional compression, because the side resistance is not going to change. But because of cost and practical aspects, I always recommend testing in tension. Now, when you're doing compression, let's say that if you have to do it, it's absolutely mandatory. It's always a trick, those reaction, because I can guarantee you every contractor in the world will always try to say, can I use some of the production micropiles as my reaction piles, right? And that could be good and that could be bad. I mean, it could be good because at the same time, it's kind of like you're testing those elements too, because you're putting load. But depending how you do the connection to that element, you may even damage the head of that micropile. So I prefer to stay away from that, go to tension and avoid all those. But in certain projects, the owner requires compression test.
Okay. Jorge Duran asks for the reference for, I guess, DM4. I guess that's DM4 and ASCE's bridge and design manual have to be used concurrently. Is that correct?
Yeah, correct. So basically, the way that we work in transportation and mostly in the US is we have ASCE, right, which is an adaptation of the Federal Highway manuals, right? So when they become basically the law, they become the ASCE manuals, right? That one you have to buy, and it's very expensive. But then the different DOTs adapt basically ASCE. They keep the same numbering and the same chapters, and they basically just do modifications. So DM4 shows the modifications of that. It can be found on Google. If you just put Pennsylvania Department of Transportation Design Manual 4, it will take you straight into a PDF, and you can download the PDF. It's free. You can also contact me on LinkedIn, and I'll send you the link. Same with the manual that we did for the Delaware State, for the Delaware Department of Transportation is also. Now, if somebody's listening to this in South America, you have even better, because in Colombia, there is what is called CCP 14, which is the Bridge Design Manual, which is a strict translation of ASCE, translated to Spanish and converted from international, from English units to international units. That one is also free. You can just say Colombia CCP 14, and you get the PDF on that. I always have a copy of that on my phone, and you save the money to paying for ASCE. So if you are abroad, you should do it. If you're in the US, don't do it. You have to pay for the manual.
Nice. Mr. Roy is asking for clarification on the design of the mini piles. You ignored end bearing. Could you please elaborate?
Yeah, so typically on micropiles, you ignore the end bearing because the area is very small, right? So if you're doing elements that are 7 inches, 9.5 inches, your end bearing is going to be very small compared to all the side friction that you have, right? So we typically ignore it and just go with the side friction. So on the micropiles, that's typically a standard practice, even in rock or soil. For the drill shafts, it's different, because when you do a drill shaft, we typically tend to combine side friction and end bearing, right? And the question always, and the science there, is how do you combine those based on the mobilization of a strength, right? So typically when you get to peak on about 1/2 inch on side friction resistance on a shaft, but you get to peak at about 5% of the diameter, at a deformation of 5% of the diameter, you get to peak on end bearing. So how you mix the two, it's always the art. But in this case, we didn't even go there, because having that claystone below, we wanted to stay away from that and just design based on side friction. But in Pennsylvania, it's absolutely acceptable to use a combination of both. And it's all explained on DM4. One more reason to download it.
Okay. Sirha of Cincinnati, again, I guess just clarify, did all the piles penetrate the sandwich claystone? Did the claystone offer any frictional resistance? He notes that he has seen some designers waiving the P reduction in the bedrock because of this.
Correct. So I mean, in practice, yes, of course, it's going to offer some resistance. In design, we ignore it, right? But in reality, it most probably is taking some of the load, right? It's just that conservatively, we ignore it. right? I mean, it could be argued too that say like, yeah, but I mean, if anything, I mean, honestly, if I have learned anything in 20 years is everything is stiffness. The load goes to where the load can be taken, right? And sometimes, you think that it may take more than what it actually does. When you have something that is a very soft material, and then you have a material under that is really stiff, right? And requires that deformation to mobilize the strength, the load typically just goes straight into the lower unit, and it doesn't go above. So, you know what I'm saying? Just the fact that it's in contact with the concrete, it tends you to believe that it could have a lot of resistance that you're ignoring, but in reality it's not, because the load really concentrates straight into the lower one. But as I said, in downtown Pittsburgh, that's this sandwich of claystone and sandstone is really what the art is, right? Is how to stay on that zone and don't punch into the one below, right? And try to minimize obviously all the drilling that you need to do in the one above. We also do a lot of, don't take me wrong. I mean, that clayston still offers resistance. It's all about the load that you're putting. We do a lot of spread footings on that when you are doing structures that have less load. So you analyze it as a stiff clay. And if you have bearing capacity enough for that, then it's okay, right? It all depends. I mean, a material is a problem or not, depending on the loading, more than the material, right?
Did you provide a bond break in the claystone?
No, we actually did not. It's basically the temporary casing went all the way to the claystone, then you drill through the claystone, and then you go that. But when you concrete, it's all in contact. And that's typically the way that is done here, right? So you ignore the resistance, but there may be some resistance, right?
Okay. If you have any questions, any further questions for Sebastian, feel free to put them in the chat.
We have 3 minutes. We can talk about the Primantis brothers, the best food in Pittsburgh, the best views in Pittsburgh. I mean, it's a great place. It's an awesome city that I absolutely fall in love with. And I absolutely want people to come here and get to see it, especially that time of the year is great. I mean, I know Brad came here many times before we met and became friends, but I think since we met, I have shown him and give him tours of different places that are even more special, right?
I hadn't seen the Panther before. For some reason, I had never gone to the Panther before. So I think we need to do a couple things here. The first one is, do you have a prediction for Saturday's game? To give you a minute to think,
I don't need it.
I'm going to say that WVU runs all over the Pitt defense, and I'm going to go 30-17, I think is my final. God. WVU wins.
My friend, you could not be farther from the truth. I don't know if you watch on Saturday how Pitt did the biggest comeback in Pitt football history since like the 50s or something like that. And on a game that Cincinnati was winning and we were out on the third quarter, we came back and won it by 1 point. Yeah. So I think spirits are high. I feel Pittsburgh is going to win at least by 10 points. So I'll leave you on that one.
So the other things here is, I can't believe Governor Wolf didn't think it was funny that you guys shared a name. What is up with that?
I know. I think the people from the Secret Service or whatever were more concerned than him. But yeah, when I said, I think, Governor, I think
who's this guy with the accent?
Yes, I know. And I was like, especially saying, Governor, I think we're family. And, I'm sure like he's like, all right, let's remove this guy from here.
The last time somebody said that, it didn't end too well.
Yes.
Correct. So then I did put a link in the chat for everybody to go watch the interview that you did with Rick Seaback on the Gumbands podcast. So everybody should check that out as well. It's a great interview. WQED is one of the best PBS stations in the country, and this is a phenomenal show he does. So then the last pitch we have to do here before we wrap up is, Sebastian is also going to join us as our guest on Terzaghi Day this year. For all of our viewers, on Carl Terzaghi's birthday, October 2nd, we get together, we have a live stream, we have a Terzaghi tree. It's kind of over the top, but in a fun way. And so join us and Carl on October 2nd. Sebastian will be our guest speaker. That'll be at 2 p.m. right on our YouTube channel. So I think those are all the pitches. Jay, Sebastian, thank you guys. You did an excellent job today. I think great job giving everybody a flavor of Pittsburgh so they can get ready for this. for all of our viewers out there, thanks for all your questions. Thanks for watching. I hope you liked what you saw. You're here at the end, so you probably did. And of course, that means click like, subscribe, and get notifications, and we'll let you know every time we post something to the YouTube channel. 2 more live streams in the GI Summer of Live. They are both next week. On Tuesday, join us for part 5 of Keller's sustainability series with Don Davies talking about embodied carbon. And then next Thursday, you want to join us for the 2024 Monosmith Lecture. It's our annual lecture named after legendary Berkeley professor Carl Monosmith on pavement engineering. And this year, our lecturer is Sohail Nazarian of the University of Texas at El Paso. That's also at 2 o'clock. Next Thursday, we hope you are there for one or both of those. So, Jay, Sebastian, thanks again, guys. I hope it was fun.
Thank you, Rob. Thank you, Jay. Awesome. Nothing like a Colombian sailing Pittsburgh.
We'll see you all in Pittsburgh in November, please.
Perfect call. And we'll see all.
Absolutely.
Well, Matt Roberts was our producer today. Got to give him a shout out.
Thank you, Matt.
And we will see everybody next week.